Good day to all of you. Today we shall study chapter 2 in DBMS, Database System Concepts and Architecture. Our sincere acknowledgement and thanks to authors Ramesh Elmasri and Shamkant B. Nawate, the authors of the textbook being Fundamentals of Database Systems. The whole content of discussion I am taking from this textbook. First, let us know what is database schema. The description of a database is called as database schema. So description means describing, database means it is collection of tables. So describing the collection of tables, that is called as database schema. What is schema diagram? So schema diagram means if schema is represented in the form of diagram. That is, if description of a database is given in the form of a diagram, that is called as schema diagram. So this figure shows an example schema diagram. This is schema diagram for university database. It is shown to have 5 tables: student, course, prerequisite, section and grade report. Student table is shown to have the columns name, student number, class and major. Course table is having course name, course number, credit hours and department columns. Prerequisite table is having course number, prerequisite number as columns. Section table is having section identifier, course number, semester, year and instructor columns. Grade report table is having student number, section identifier and grade columns. So this is what is an example for schema diagram. Okay. So the next term that we should know is database state. The data in the database at a particular moment in time, that is called as database state or snapshot. Means database will be having tables. So whatever values are stored in the tables. So the data in the database means the data stored in the tables at any instant of time. That is called as database state or snapshot, or it is also called as current set of occurrences or instances. The schema is sometimes called as intension and database state is called as extension of the schema. One more term which we come across is mappings. So DBMS schema architecture has different levels. The correspondence between these different levels in DBMS schema architecture, that is called as mappings. So next we shall know what is tree schema architecture. Schema means overall description of database structure. In tree schema architecture, schema is defined at 3 levels. That is, first one internal level, conceptual level, external level. So this figure shows 3 schema architecture. So this is internal schema. Next we have conceptual schema. Next we have external schema. External schema is also known as view schema. Conceptual schema is also known as logical schema. Internal schema is also known as physical schema. As already said, internal level schema is also known as physical level schema. Physical level schema describes actually how the data is stored onto the storage medium, that is say hard disk, and access paths for the database. It has details like file organization, indexing methods and data storage formats. It is primarily used by DBA, that is database administrators and programmers. This figure shows internal schema or physical schema. Here the table is employee table. It is having 5 columns. The column names being EMPNO, ename, salary, DPTNO, post. So 5 column names are shown here. So the first column EMPNO starts from first memory location, that is byte 0, that is first memory location, first byte in the memory space. So this is 0 byte. Next, second byte of memory space, it's byte 1. Next, byte 2 memory space, byte 3 memory space. So from here to here 4 bytes of space. So offset 0 means storing of EMPNO is from first byte, that is byte 0. It continues till byte 3. Totally it occupies 4 bytes of memory space. What kind of data is stored? Decimal kind of data is stored. What is the nature of data here? Unique. Means no two rows can have same EMP number in the table, because in real life no two employees can have same EMP number. Okay. So next column, if you consider E name. So what kind of data? String means characters. Offset 4 means, so 0 to 3 is over. So next memory space, that is byte 4. From there E name is stored. How many bytes of space is reserved there? 15 bytes of memory space is reserved. That is what is length 15. Offset 4 means from byte 4 that E name is stored. Then what kind of data it is? String. This is how all the column is described. This kind of description, it is called as internal schema or physical schema. It is describing actually how the data is stored onto the disk. Okay. So the next level, that is second level, is conceptual level schema, or it is also called as logical level schema. This level schema hides details of physical storage structures. It concentrates on describing entities, data types, relationships, user operations and constraints. So this is used when a database system is implemented. So DBAs, that is database administrators and programmers, work at this level. So this figure shows conceptual schema or logical schema. So the same 5 columns of employee table we can see here. So instead of giving physical details, here at the logical level the table is described. Means EMPNO column stores integer kind of data, the length of data being 4, and this is the E column. Then E name stores string type data, its length is 15 bytes of space. Salary, string type data it stores and length is 8 bytes of memory space. DPTNO column stores integer kind of data and length is 4 bytes of memory space. Post column is storing string type of data and its length is 15 bytes of space. So this kind of describing is called as conceptual schema or logical schema, actually which hides the details of physical storage structures. Okay. Next, third and the last level is external level, which is also known as view level schema. It includes number of user views. So this is view 1, view 2. First viewer is viewing only 2 columns of employee table. Though there are 5 columns, in his view he is looking at only 2 columns content from that table, that is EMPNO column and ename column. The second user is viewing 4 columns of data. One column is hidden here. So each view schema describes the database part. Here not all the 5 columns but few columns, that is part of the table that is viewed by the viewers as per their interest, hiding remaining columns. The view schema describes the end user interaction with database systems. So the process of transforming requests and results between the levels is called as mappings. In other words, the correspondence between the different levels in the DBMS schema architecture, that is called as mappings. So with respect to 3 schema architecture in DBMS, the correspondence between the 3 levels is called as mapping. There are basically 2 types of mapping in the database architecture: conceptual to internal mapping, second one external to conceptual mapping. So conceptual to internal mapping, it lies between conceptual level and internal level. Its role is to define the correspondence between the records and the fields of conceptual level, and the files and data structures of the internal level. Next, external to conceptual mapping that lies between external level and conceptual level. Its role is to define the correspondence between a particular external and the conceptual view. It is necessary to transform the request from external level to conceptual schema. So this mapping is explained with respect to three schema architecture in DBMS. That is this figure. So it shows the three schema architecture. Here we have three levels: internal level, conceptual level and external level. The correspondence between conceptual level and internal level is called as conceptual to internal mapping. The correspondence between external level and conceptual level is called as external to conceptual mapping. These are the two kinds of mapping. So that is all about three schema architecture and the two kinds of mappings. Okay. Next, what is data independence? Data independence with respect to three-tier architecture is the ability to modify the schema at one level of the database system without altering the schema at the next higher level. There are two types of data independence: logical data independence and physical data independence. So the first one, logical data independence, it is the capacity to change the conceptual schema without having to change the external schema or application programs. So we may change the conceptual schema to expand the database by adding a record type or data item, to change the constraints, or to reduce the database, that is by removing a record type or data item. If we do any changes in the conceptual view of the data, then the user view of the data would not be affected. Changes can be applied to conceptual schema without affecting the external schema or application programs, and that is called as logical data independence. So for example, if you consider this following table, it has three columns: ename, id and dept. So now one more column is added to this table. Okay, so instead of 3 now it is having 4 columns. So this will not affect the user view. If user is viewing ename id, even after adding one column, he can have the same view. So if you do any modifications at the conceptual level, then there is no necessity of altering at the higher level, means that is at the view level. That is called as logical data independence. Next, second one is physical data independence. It is the capacity to change internal schema without having to change the conceptual schema. So changes to internal schema may be needed because of some physical files were reorganized. For example, by creating additional access structures to improve the performance of retrieval or update. If we do any changes in the storage size of the database server, then the conceptual structure of the database will not be affected. Physical details such as exact location of data on disk and hardware details of storage, encoding, placement, compression, splitting, merging of records, and so on are hidden from the user. Applications remain unaware of these details. Now with respect to this figure, that is three schema architecture, any changes you do at physical level, then no need of altering at conceptual level. That is called as physical data independence. So if we make any changes at conceptual level, no need of altering at the external or view level. That is called as logical data independence. So the question is, why data independence is required? Traditional systems have very low level of data independence. Means traditional systems means here file systems. They have low level of data independence, meaning a small change to the data structure, that is either adding or deleting the field in a date record structure if we do, then file related programs also have to be changed. So that requires multiple program changes. A small change in the structure of database may lead to rewriting all the application programs. This is very time consuming and costly. To avoid this, data independence is required. That is all about data independence, the types of data independence, and why data independence is required. So the next topic is database languages in DBMS. Database means collection of related data which the user has stored onto the computer storage medium, that is hard disk. DBMS is the software that acts as the interface between the user and the database. So to access the database, the user will be writing some commands or giving commands to the DBMS. They are called as queries. For that he will use languages and interfaces. So DBMS languages are the collection of commands, and there are 4 different collection of commands and they are given 4 different names. So the first set of commands or the first type of DBMS language, that is DDL, data definition language. It is one set of commands. Another set is DCL, so that is another database language, that is data control language. The third one is data manipulation language. Fourth one is transaction control language. Okay. So next we shall see what is data definition language, that is DDL. DDL or data definition language, it actually consists of SQL commands. SQL means structured query language. That is the language used to form the commands required to access the database. So these DDL related SQL commands, these are used to define, alter or delete database structures such as tables, indexes and schemas. Under this we have create, alter, drop, truncate, rename and comment commands. So now we shall see what these DDL data definition language commands do or what for they are used. Create command. It is used to create objects in the database like tables, indexes and views. So whenever we want to create database or tables or views, we use create command. It's a data definition language command. Next, second one is alter command. It is used to alter or change the structure of the database. For example, to add a column to the existing table or modify or delete columns, as well as apply constraints such as primary keys and foreign keys and make other structural changes to the table. Third one, drop command. It is used to delete objects from the database. That is, if we drop a table, not only the content of table is deleted, but its structure also gets deleted. Fourth one is truncate command. It is used to remove all the records from a table without removing the structure. We cannot roll back this. Truncate command can delete all records, not one or only few records. So that is the difference between the next command which we studied, that is delete. Delete command can delete only one row of data or multiple row of data depending on the condition given in where clause of the SQL query. But truncate command can do deletion of only all the records. There is no choice in this. And like delete command, it will not remove the structure. But delete command can be rolled back. This truncate command cannot be rolled back. That is the difference. So rename command. It is used to rename an object like table, column or index. Next, comment command. It is used to insert explanatory text within the command. So this explanatory text means whenever we write a command or set of commands, the purpose for which we are writing that. So those lines of text can be included with the comment command. They will not be executed, but for user reference and for documentation purposes, that text will be maintained. Okay. So these are few DDL commands. So second type of database language is data manipulation language, that is DML. DML stands for data manipulation language. It is used for accessing and manipulating data in a database. So it can handle user requests. Under this we have select, insert, update, delete, merge, call, explain plan, lock table commands. So next we shall see DML commands one by one. So the first command is select command. It is used to retrieve data from a database. Insert command. It is used to insert data into a table. Update command. It is used to update existing data within a table. Delete command. It is used to delete one or all records from a table. So now already we studied one command, that is truncate command. So it belongs to DDL, that is data definition language, that can delete only all records. There is no choice there. But using delete command, which is DML command, we may delete only one record or two records or any number of records, not only all, depending on what condition we specify in where clause of SQL query. That is the first difference between truncate and delete. So truncate is DDL command, delete is DML command. Truncate can delete only all the records, but there is choice how many records we want to delete in delete command. Next, there is no rollback in case of truncate command. There is rollback in case of delete command. But the common thing is both delete the content without deleting the structure. Okay. So that is the comparison between truncate and delete command. So next we shall move on to merge command. It is used to perform upsert operation. That is, it combines both update and insert operations into single statement. So next command is call. It is used to call PL bar SQL. That is a set of pre-compiled SQL statements or a Java subprogram. Next one is explain plan. So this command describes the sequence of operations the database performs to execute a SQL statement. Lock table. So this command is used to lock the table for preventing access from the users. So this command is used in concurrency control. So these are some of the DML commands. Next, the third type of DBMS language is data control language, that is DCL. So DCL stands for data control language. The commands under this, they are used to control the access permissions of the users to the database. DCL commands are transactional, meaning they can be rolled back if necessary. Means when permissions given, they can be taken back also. So grant and revoke command come under DCL. Grant command is used to provide specific permissions or privileges to users or roles over databases. Revoke command is used to remove previously granted permissions or privileges from users or roles. So grant and revoke commands are essential for managing access control, ensuring that users do not have more privileges than necessary to perform their task. Using this command, DBA administrator, that is database administrator, can authorize the user to access the database or remove the authorization. So there are the following operations which have the authorization of revoke. So authorization for connect, insert, usage, execute, delete, update, select. So these operations user can do over database only when he is given corresponding permissions or privileges by the database administrator. Next, the fourth one and the last one DBMS language is transaction control language, that is TCL. TCL is used to run the changes made by the DML statement. TCL can be grouped into a logical transaction. So commit and rollback commands come under TCL. So commit command is used to save all the changes made during the current transaction to the database. Rollback is used to restore the database to original since the last commit. In simple words, commit command is used to save the changes made to database whenever user executes queries. Rollback command is used to undo the changes made by user queries till last commit. Okay, and that is all about DBMS languages. So next let us know what is meant by DBMS interfaces. DBMS interfaces act as the interface or mediators between user and DBMS software. They are used by the users to give queries to the DBMS software. Okay, there are different types of DBMS interfaces. The first one is menu based interfaces. These are meant for web clients or browsing. In this menu, which is a list of options, is provided. Clicking on any one option in the menu, an operation can be performed by the user. Here user need not remember complex command and syntax. The second one is form based interfaces. So form based interfaces, they present the data in structured format like a form with fields for input. User can enter the data directly into the form and do the operations, allowing them to fill in the fields to insert, update, delete data, and the system handles the underlying database. The third one is graphical user interfaces. These use visual elements like menus, buttons, and icons to allow the users to interact with DBMS. GUIs, that is graphical user interfaces, can display schema to the user in diagrammatic form, allowing them to specify queries by manipulating the diagram. So the next type of interface is natural language interface. These interfaces accept requests written in English or some other language and attempt to understand them and generates high level query which corresponds to the entered text. Next, keyword based database search. This allows users to find data by entering keywords or phrases. Like in Google, we enter keyword or any word whatever we enter onto the Google search. Depending on that, it will display the web pages. That kind of interface is called as keyword based database search. So it allows the users to find data by entering keyword or phrases. The system then searches the database for records that contain these keywords or phrases. So when we enter a keyword onto Google search, so in Google database, it searches for the keywords and which matches those websites it will be displaying. Okay. Next, speech input and output interfaces. These allow users to query and receive responses using speech. So these are useful for disabled people. Next interfaces is interfaces for parametric users. These interfaces contain some commands that can be handled with the minimum keystrokes. It is generally used in bank transactions for transferring money. These operations are performed repeatedly. Interfaces for DBA, that is interfaces for database administrator. So command line interfaces, graphical user interfaces, and specialized tools for Tasks like creating accounts, setting parameters, and managing schemas all accessed through privileged commands. And such interfaces, they are especially used by database administrator. The last one is apps for mobile devices. Mobile apps often interact with databases to store, retrieve, and manage data using various DBMS technologies. And that is all about DBMS interfaces. Next, we shall discuss the most important topic, that is database system. In that, component modules of a DBMS and their interactions. So this figure illustrates in a simplified form the typical DBMS components or different modules that are present in DBMS software. There are two parts here, top part and lower part. So this is top part and this is lower part. In the top part, users of the database environment and their interfaces are shown. So here user section, that is DBA staff, casual users, application programmers, and parametric users. So users of the database environment and their interfaces. So this part is interfaces and this part is users. Both together is shown in the top part. Okay. Lower part, that is this part, shows the internal modules of the DBMS responsible for storage of data and processing of transactions. Now we'll discuss the different modules. The database and the DBMS catalog are usually stored on the disk. Operating system controls access to disk by scheduling disk read-write. Buffer management module of OS, that is operating system, schedules disk read-write. Next we have stored data manager module. So this module, which belongs to DBMS software, that controls access to DBMS information that is stored onto the disk, whether it is a part of the database or the catalog. So now if you refer to this figure, store data manager is here and the database will be stored here. Data about data or metadata will be stored in the catalog file here. So for this data and metadata, if any access is required, that is controlled by store data manager module. Okay. So the next module is DDL compiler. So it processes schema definitions specified in the DDL, that is data definition language commands, and stores descriptions of the schemas, that is of metadata, in DBMS catalog. So again, if you come back to the figure, this is DDL compiler. Actually it stores database schema or schema definitions onto the disk here. Okay. So the next module is interactive query interface. So the casual users and the other users with occasional need who want to access the database for any information, so they will be using this interactive query interface to enter the SQL queries. The query compiler compiles the queries. Okay. So in the figure, query compiler is here. So when casual user enters the SQL query through interface, this query compiler will compile the query. Okay. The next module we have query optimizer. After compilation, this query optimizer rearranges and does possible reordering of operations. It eliminates redundancies if any. It uses efficient search algorithms during execution and see that compiled query is executed efficiently. So that query optimizer is here. So after compilation by query compiler, this query optimizer rearranges. So what if any redundancies are there, it removes and it will say that the query which is compiled, it is executed in the efficient manner. Okay. The precompiler module extracts DML commands, that is data manipulation commands, from an application program which is written in host programming language. Instead of entering directly the query, he will have entered application program, say which is written in Java. Java is the host programming language here. So in that Java program, SQL queries will be embedded. So this pre-compiler will extract only that SQL queries from the application program and they are sent to DML compiler, and the remaining part of the program will be sent to host language compiler. Figure we can see pre-compiler. So application programmer will have entered the application program, say written in Java program. In that SQL queries are embedded. This pre-compiler will extract those SQL queries and it will send them to DML compiler, and remaining Java program part it will send to host program compiler, and it will compile Java part, and this DML compiler will compile SQL part. So that is all about upper part. In the lower part, runtime data processor, it executes the privileged commands, that is the commands given by DBA administrator, that is database administrator, and the executable query plans and the CAN transactions with runtime parameters. It works with the system catalog and it may update that catalog with statistics. It also works with stored manager. So this runtime database processor is responsible for execution of query finally after compilation. So in the lower part we have runtime database processor. So it actually executes the compiled query. For that it will take the help of metadata and store data manager. It will be accessing the data from database and it will be executing the query with the help of metadata and store data manager. So concurrency controller, backup and recovery subsystems which are shown here, they will be helping the runtime database processor in executing user compiled queries. Okay. So concurrency control and backup and recovery systems, they are shown separately in the figure. They are integrated into the working of runtime database processor for purposes of transaction management. The client program. Next, the client program. Client program means user program. It accesses DBMS running on a separate computer, so on which databases do reside. That separate computer is called as database server, and the computer in which client programs are present, that is called as client computer. So this is client computer and this is database server. So from client computer the queries will be submitted to database server over the network. From database server the information retrieved is sent back to client. So this is called as two-tier architecture. In many cases, client accesses middle computer called application server, which in turn accesses database server. That is, there will be three computers. This is first one client computer, second one application server to which the client computer will submit the query. This application server in turn accesses database server, that is another computer. For that the query will be submitted by application server. Whatever information is retrieved from database server, it is given back to application server, and that application server will give that information to client. So this is called as three-tier architecture. And that completes the discussion on the different component modules of DBMS and their interactions. Okay. Next we shall see what are database system utilities. So database utilities are the programs. They help database administrator to manage the database system. The common utilities are, first one, loader. So loaders are used for loading purpose. It will load the data from external files into database tables. Transferring data from one DBMS to another Nowadays, it is becoming common in many organizations. Some vendors offer conversion tools that generate the appropriate loading programs given the existing source and the target database storage descriptions, that is internal schema. So from source files the data is loaded onto the database onto the disk. This work is done by loaders. Database storage reorganization. These are the tools that allow administrators to reorganize a set of database files into different file organizations, create new access paths to optimize storage space, and improve performance. These utilities include tools for indexing, defragmentation, and data compression. Next, tools or utilities for backup. These backup related programs allow creating copies of database for disaster recovery purposes and restoring data to a previous state in case of failure. Next, performance monitoring utilities. These tools monitor database usage and provide statistics to DBA. The DBA uses the statistics in making decisions such as whether or not to reorganize files or whether to add or drop indexes to improve performance. So DBA plays a very important role in getting the efficient performance by the database system. The other utilities may be available for sorting files, handling data compression, monitoring access by users, interfacing with the network, and performing other functions. Okay, and that is all about database utilities. And that completes the discussion on several topics from the second chapter. I hope you understood. Thank you.